Hi everyone, this is lesson 4.1.1, and in this lesson we're going to look specifically at rotation angles, but we're also going to talk about reference angles and converting between degrees and radians. Example 1.
This question says, for each of the following rotation angles, provide a sketch, identify the reference angle, and then give a general expression for the coterminal angles. Okay, so let's take a quick look here. Let me zoom in just a little bit here. Whoops, wrong direction. So, for 220 degrees, now let's just think, what would this rotation angle look like? Well, a rotation angle always starts on the positive x-axis. Here's our initial arm. Now, 220 degrees, okay, is going to put us back here. This is 90, this is 180. So 220 is going to be somewhere down here, okay? Now, I don't really have to be 100% accurate with that, just as long as it's in the right quadrant and it's roughly in the right, pointing in the right direction. That's really what I need here. And so this is going to be our rotation angle, and I really should draw that line in there to connect the initial arm and the rotation arm, the terminal arm here, just so that I can differentiate between this angle, for example, and this angle, or an angle that goes around a little bit here. Okay, so this is my rotation angle. So let's say here theta is equal to 220 degrees. The reference angle is always the smallest, okay, the smallest, or I shouldn't say that. I should describe it this way. The reference angle is the acute angle between the terminal arm and the x-axis. So in that case, this right here is going to be our reference angle. Because when we draw our triangle here to do our trig, or define our trig functions, it's going to be this right here. So this is going to be our reference angle. And I typically use the symbol alpha to refer to that. So alpha here, in this case, because I am beyond the x-axis here, I've rotated around here, I've gone beyond the 180 degree mark. What we do here to get the reference angle is going to be 220 degrees minus 180 degrees. Okay, that line right there. So that what I'm going to get here is this little bit left over, and it turns out here, just think about it, 220 minus 180. Our reference angle is 40 degrees. Okay. Really important, a couple things that you get here. The reference angle is never to the y-axis. You should never be using 90 degrees or 270 to be calculating the reference angle. If you do that, then all of a sudden all of our trig definitions, our sine, cosine, tan being y over x, y over r, x over r, and y over x, those all change completely for those if you start to make this your reference angle. This is how we want to do it, just for consistency's sake here. It's always between the terminal arm and the x-axis. Okay, I really can't overstate that. Now, give a general expression for all the coterminal angles. Okay, well, to come up with all of our angles there, all of the coterminal angles, and maybe what I'll do is I'll use my little theta with a subscript c to refer to all of my coterminal angles here. I'm going to start with our principal angle. Okay, and our principal angle in this case is 220. That's the smallest positive angle, okay, that takes us out to that terminal arm. Now, to that, I can add, okay, 360 degrees times n, okay, because I don't know how many times I'm going to add that 360 degrees, but I know that if I want to get back out to here, I got to keep going around and around that circle, okay? So I'm going to add 360 degrees, and I'm going to let n be an element of the integers. Now remember, we use the z similar for the integers. And the reason why I want integers here, not real numbers, because I want to go around and around and around forward however many times, and I'm using integers because I want to do full rotations. Not fractional rotations, but full rotations. Positively and negatively going around to get to that same answer there. So there's the first one. Now let's come over here and take a look at the second one here, 780 degrees. Now to do this correctly, what I need to do is figure out what the principal angle is for that. Now this goes all the way around the full circle. So starting on our positive x-axis, there's our initial arm, I know I'm going to go around at least once here. Okay, because 780 is larger than 360. So 780 minus 360, actually I'll show you this on my calculator here, I do this real quick. 780 minus 360 is 420. Well, that's another full rotation around. So I've gone around the circle twice. So what I'll do here is I will take from that 420 and I will subtract another 360. And I get 60 at the end there. Okay, so that means that I've gone around twice, and then I come around, and my terminal arm is going to be somewhere out here. So here we go. My theta here, my rotation angle is 780 degrees, but my principal angle was just 60. Okay? Now, next thing that we want to do here is we want to identify the reference angle. Well, the reference angle, once again, is going to be the angle, the acute angle between the terminal arm and the x-axis. So that reference angle is going to be this guy right here. There's my theta, or my alpha, I should say. And because I'm in quadrant 1, actually it works out, this is quite straightforward. This is simply going to be 60 degrees. When we're in quadrant 1, the rotation angle and the reference angle is just equal to that principal angle there. And so now for my coterminal angles, all of those angles coterminal to that angle right there will be, again, I'll use theta c here. Now, I could put 780 there, but you know what? The kind of the standard way of doing this is to throw your principal angle there plus 360n, where n is an element of the integers. And I don't need to do plus or minus here, because when I'm talking about integers, that includes positive and negative values of n. So that will encompass that all together. That's typically how I would write that. Now, what's important about these coterminal angles, for you to remember here, is the coterminal angles all are going to have the exact same trig ratio values. Okay, as far as sine, cosine, tan is concerned, 780 and 60 degrees, they're basically the same. And anything that's coterminal to that terminal arm is going to be the same. Now let's come over here and take a quick look at this one. 4 pi over 3. Okay, now the way I take a quick look at this here, what I'm going to do here is I'm going to, just for the time being, just notice that I've got pi. Don't worry about the 4 here. I've got pi over 3, which means, remember this angle up here, okay, that 180 degrees, that's the same as pi radians. And so what I'm doing is I'm dividing pi radians into thirds. And if you divide the top part into thirds, I'm dividing the bottom part into thirds. Now don't worry about the x-axis here. Please don't, the y-axis. Don't let that throw you off. Here are my thirds. 1, 2, 3, 1, 2, 3. So I know I haven't done that really, really well here, but you get the idea. 4 thirds of pi is going to be 1, 2, 3. I'm sorry. I can't believe I did that. No, that's right. 1, 2, 3, 4 to get us down into the third quadrant here. So here's my reference angle at 4 thirds of pi. Now, I would like the reference angle. Now the reference angle, just like in A there, is going to be the angle between the terminal arm, the acute angle between the terminal arm and the x-axis here. So here's my alpha. Now, there is a little shortcut for figuring out the reference angle that applies to basically any question you get in high school. And here's the shortcut. I'll show you right now. Take a look at your original angle here. Here's the shortcut. There. You want to see it again? Pi over 3. There it is. Pi over 3. The reason for that is because when we talk about angles in radians, we're always talking about fractions of pi. Well, that fraction of pi there, that becomes the reference angle. And then the numerator simply tells you how many of those you're going to incorporate. So that's why it's always easy just to knock off that coefficient up there, and then what you're left with, that's your reference angle. Now, for coterminal angles, okay, write out all my coterminal angles, I'm going to start with, I'm going to start with my principal angle, which is just going to be this guy around here, the smallest positive angle, and that's 4 pi over 3. No reason to change that. And I will add, now instead of adding 360 this time, I'm going to add 2 pi times n. And once again, I will let n be an element of the integers. Okay, implying that I can go around and around and around as many times as I want, as long as I do full rotations. Now, our last one here, 23 pi over 6. Okay, well, I am going to be chopping up pi into sixths. Okay, so that means looks something like this. So I've chopped up the top half of the circle into sixths. I'm going to chop the bottom half into sixths. Okay, this time I am using the y-axis here. So now starting on the positive x-axis, I'm just going to count this out here because I've got 23 of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I've gone all the way around the circle. That was 12 sixths of pi, and there's 2 pi. I keep going, so it's 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There we go. There's where our angle ends, in the fourth quadrant. This little bit right here, sorry, I should write that out here. So our rotation angle was 23 pi over 6. And it took us all the way around to here. Okay, our principal angle was just the smallest positive angle to get us out to there. Now, if I just count that out here, just going around here from the positive x-axis all the way around here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 11 of these little pi over 6 wedges. So my principal angle here is 11 pi over 6. My reference angle is just going to be this little bit right here. And again, I'll show you that little shortcut here. Go back to the original angle. Just cover up the 23, and I've got pi over 6. There it is. There's my reference angle. Okay? And again, that's the smallest, that's the acute angle between the terminal arm, right there, and the x-axis. Now, my coterminal angles. Okay, once again, I start with the principal angle typically, so it's going to be 11 pi over 6 plus 2 pi times n, where n is restricted to be an integer. And there we go.
Example 2.
This question says, convert the following angles to degrees, rounded to the nearest degree. Okay, now I'm going to do this a couple of different ways. First of all, we're going to take a quick look at the conversion factor, and this is important. Although I'm going to show you what is likely going to be considered a better way of doing this, there are lots of times where knowing that conversion factor and just being able to incorporate it into a question actually is a huge benefit to us. So we want to convert from radians to degrees. So we start, here's our 4 radians, okay? Now I don't really need to put a unit there. In fact, I really shouldn't, because a radian is a dimensionless measure here. My conversion factor, okay, is going to be such that I'm left with a degree up here, and then I use my radians down here. And the easiest way to compare these two is to simply work it like this. If I put 180 degrees on top, I know conceptually that that's equivalent to pi radians. Okay? Now, I know, okay, this is, conceptually this is 1. It's not numerically equal to 1. It's really important that you catch that. That isn't the number 1. But conceptually, these are identical, and so the fallout of that is that you really are, in essence, multiplying by 1 here. Now, we are, however, interested in what that numeric value is. So what we'll do is we'll go to the calculator, and we will multiply 4 by 180 divided by pi. And we get that that angle in degrees is 229.2 degrees. Oh, sorry, rounded to the nearest degree. My mistake, 229 degrees. 229 degrees. Okay, this is approximately 229 degrees. Now, there is another way of doing that. Let me show you how to do this on your calculator. We're going to convert radians to degrees. Now, what we do here is we're going to make sure that we are in degree mode. Okay? Make sure I'm in degree mode. I need to be in the mode that I'm converting to. And now I'll quit. So second quit. And now what I'm going to do here is I'm going to put in brackets here 4. Okay? Now, I don't always have to put these things in brackets. I'm putting this one in brackets because when I use this tool to convert to, well, back and forth from degrees and radians here, if you just use brackets all the time, parentheses all the time here, you'll never run into little mistakes that could pop up. So if you just get used to doing that all the time, that's good. Now, what I'm going to do here is I'm going to take you to a menu here that very seldom gets used, and that's this one right here. Okay, so I'm going to press Second Apps to access the angle menu. Probably not a menu you get to that often there. And this is the screen that opens up here. And what I want to do is I want to come down and I want to identify that the measure, the number 4 that I'm looking at here, is a radian. That's what that means right there. So I'm going to press enter. And so this is telling the calculator that I've got 4 radians. And when I press enter, because the calculator is in degree mode, it will convert that angle there to degrees. Okay, let's do the same thing over here with part B. 7 pi over 3. Now this one's actually a little easier to work with. And I'm going to, again, do this in 2 different ways here. First of all, we're going to take and do this with the conversion factor. So again, I'm going to multiply by 180 degrees over pi radians. Now, in this case here, actually, we can do this a little bit quicker even. The pi's will cancel, okay? The pi's will cancel. And so the fallout of this, or the shortcut, if you will, is you can really just replace the pi with 180 if you wanted. That's essentially what's going on here. So on my calculator, I really am just going to make this 7 divided by 3 times 180 to get 420 degrees exactly. So this will be 420 degrees, 420 degrees. Now I'm going to do that using the other method that I just showed you here. And in this case here, I really do need the parentheses here. So 7 pi divided by 3, and I put that in brackets there, make sure that they're in parentheses. And now I'm going to go back into that angle menu. Okay, and remember where I'm getting that from. It's the second apps to get that angle menu. And again, I'm going to come down here and identify that that is in radians. So I press 3 there, and there we go, 7 pi over 3 radians. Press enter, 420. Good.
Example 3.
Now this question says, convert the following angles to radians in both exact form and rounded to the nearest hundredth. Okay, so we start with 130 degrees. Now, first thing I want to do here is talk about the conversion factor. So we start with 130 degrees, and we're going to multiply by a conversion factor here that's going to get rid of the degrees, so cancel that out and leave us with radians. And remember that the relationship here is that 180 degrees and pi radians are basically the same thing, so I can use the ratio between them to do my conversion here. This time, though, I'm going to put pi in the numerator because pi represents the radian measure that is the same as 180 degrees. And so here you can see that the degree measures here would cancel, or sorry, the degree units would cancel, be left with radians. Now, I know that I'm going to be left with an answer with a pi in it. Okay, so one of the things I can do here is I'm going to be left with, I'm going to end up with 130, really, divided by 180. Now, I don't really need to go through the process I'm about to show you here, but I'm just going to do it anyway because I want you to see it. I don't need to write the pi in there because I'm going to be left with the pi anyway. And you get 0.7222. Now, if you can't already see how that would simplify, because normally we would want to write that fraction in simplest form, then what you do once you get that decimal here is you're going to press the math button right here. As soon as you've got that decimal, you have to have that decimal first, but then press the math button. And the very first option you get here is to convert to a fraction. So press enter to choose that. And what we'll do here is it'll take that answer and convert it into a fraction for us. And so this becomes 13 over 18 pi. Okay, because I couldn't do anything with the pi. I left it in there, didn't do anything with it. Now, I'm also supposed to put this in exact form, which is what I've got there, because this pi represents that value exactly, okay? But I also would like to do this to the nearest hundredth, so I'm going to multiply this by that value of pi, just to see what I get. And I get 2.268, okay, blah, blah, blah. To the nearest hundredth will be 2.27. Just round the ones there. So this is now going to be approximately 2.27. So those are the two values that we want to get there, okay? So it's exactly equal to 13 pi over 18, and it's approximately equal to 2.27. Now, let's go through here, and I want to show you how to use your calculator in a similar way that I did before here to convert this into radians here. First of all, we're going to press mode, and we're going to go and put the calculator in radian mode. I want it to be in the mode that I'm converting to. And now what I'll do is in parentheses here, I'll put 130. And then again, I'm going to go into my angle menu by going second apps to access that menu. But this time, I need to tell the calculator that what I'm looking at is a degree. So I just choose number 1. Whoops, let it focus here. So that's telling the calculator this is 130 degrees, press enter, and I get 2.26. Okay, that's the decimal that I got before here. Now, you don't fall into the trap of assuming that the calculator can't give you what the exact form is. Okay, the calculator can actually tell you what this angle is in exact form as well, but you got to help it out a little bit here. This right here is the decimal value. The reason why it's such a complicated decimal here is because there is a pi in that angle. So for the time being, let's just get rid of it, okay? So like look over here, I already know that this is supposed to be 13 over 18 times pi. That pi is creating this bizarre decimal. So what I'm going to do here is out of that angle, I'm going to divide out the pi. And now, if I take and go to my math menu, convert to fraction, if I convert that to a fraction, I get 13 over 18. And now what I can do is put that pi back in. But don't put it in as a decimal value, put it in as the pi symbol, and then you would get 13 over 18 pi. Now, if you're not quite following me on that, I tell you what, this is what we're going to do here. We're going to slide over question 2 here. I'm going to do this one in the method that I just described, and then I'll go back and we'll talk about it using the conversion factor here. So what we're going to do here is we're going to take 315, put it into our calculator. Now we're going to go into the angle menu, pressing second apps, and I'm going to tell the calculator that what we're looking at here is a degree measure. When I press enter, I'm going to get 5.49 blah blah blah. Okay, so rounded to the nearest hundredth, which is what this question's asking, is well, round that up. Okay, so it's going to be 5.50. So this is going to be approximately 5.50. Now I'm giving myself a little space here because I'm going to get the exact form here in just a second. Now that's a kind of a bizarre decimal there, but the reason why the bizarre decimal there is because there is a pi in that number. So let's divide out the pi just for a second here. Get rid of that. That leaves us with 1.75. Now if you're not sure what that is as a fraction, you just press math, choose the fraction operation there, press enter, and I get 7/4. Okay, so now put the pi in. We took it out a couple seconds ago. Now let's just put it back in, but let's put it back in as a pi symbol. And so this is 7 pi over 4. That's the exact value that we were looking for. So the calculator can give you those both to you as long as you know how to use that. Now, if we were going to use the conversion factor, I would then, just to remind you, I'd have to multiply by pi over 180 degrees. Okay, so we cancel out the degree. And if you leave the pi in there and just use your calculator to convert that to a fraction, you will again get 7 over 4, plug the pi in, and once again, going to the calculator, you would get 5.50 as your decimal to the nearest hundredth. Now, it may not be 100% clear exactly how powerful this just is here. Let me show you something real quick. If you've already gone through the course, if you're just kind of reviewing some of this material right now, I just want to show you really quickly what the calculator can now do, just so that you can get a sense of how useful this little tool is. Let's say, for example, that I told you that the excuse me, that I wanted you to solve an equation that said something like this. It was something to the effect here that the cosine of theta was equal to, let's say, root 3 over 2. I just wanted you to solve that. Okay, you would use the inverse cosine feature of root 3 over 2. Now you're going to be asked to do this in exact form. And so you will be told to go to your special triangles or your unit circle, however you've memorized that. But what I'm telling you right now here is your calculator can actually give it to you in exact form. Second cosine, okay, let's make this the square root of 3 divided by 2. Now I'm getting a weird, crazy decimal here, but the reason for that is because there is a pi in that answer. So divide out the pi, then convert that to a fraction, and now put the pi back in. The angle that I'm looking for is pi over 6. I don't need to memorize the unit circle or those special triangles. They do help. This is a little bit slower, but you can always use your calculator to get around that issue as well. It's quite a useful tool.